Okay, now let's talk about why the zeAC is better than any air conditioning system in the market at the moment. There are many ways that it is better. I have experienced this thing for a few days now, and given the right amount of it in a home, the experience that I'm feeling is superior to anything that I felt in any air conditioning environment. It's not too cold. It's never too cold. It's never too hot. It just aspires to be very comfortable for the human being. But apart from that, the idea of not paying utility bills, electricity bills for heating or cooling, gas bills for heating, um, is a huge incentive. All you have to do is add water, and the bills are gone. The ZAC is simple. If you open a regular air conditioner and look inside it, you will be perplexed by the complexity. The ZAC is simply a rock shaped in a particular form. Drop it, add water, and the rest of it, the intelligence is embodied in the material. It works in any climate, unlike evaporative coolers that work in dry climates only, hot and dry climates only. The ZAC works in humid climates, in hot and humid climates, in hot and dry climates, in cold climates. It works everywhere. It just adjusts its behavior to provide comfort in any climate. I've spoken about the natural fresh air, that is occasioned by the purification of the air by the material and the plant and the constant fresh supply of oxygen. Humidity is a big problem. Air conditioning is all about dehumidification, really, and the material does it naturally, dehumidifying the air. It pulls the water out of the air. Now, one of the things I observed, looking at this, is that over the last 3 days, I've barely added any water to this. I just sprinkled water on top of it, like half a cup this morning. Um, but the water that I poured in over 3 days ago is the same water that's been in here. So what is it using to cool if it is not expending the water? Well, you see, the material cools by evaporation, but it also condenses, which is what causes the heating in the winter or when the water is cold. So condensing means condensing vapor back into water. So as it condenses water, it replaces the water that was evaporated. So giving which one is doing the most, cooling or condensing, um, it determines exactly how much moisture is expended and how much moisture is replenished. So in this instance, it's condensing a lot of moisture because this is a very humid climate, and it's evaporating a lot of moisture in order to maintain cooling. Um, and so it's going to take a longer time for the water to deplete because it's going to deplete gradually, based on the deficit between what it is condensing and what it is evaporating. Um, okay, so there are other. So in terms of water usage or energy usage, um, this is pretty simple.